Assalamu everyone. This is lecture number 2 for the course CS116 Object Oriented Programming. So let's get started. Now this is what we discussed in the last session. We compared these two programming paradigms, procedural programming and object oriented programming. We also discussed briefly what an object is and what advantages does object oriented programming paradigm provides over procedural programming. However, it is too early to appreciate this difference because we have not yet explored the main features of object-oriented programming. But after next 2-3 sessions in which we'll be doing this, you will be able to understand this difference more clearly. In today's session, we'll discuss in detail with examples the concept of classes and objects, and also the concept of encapsulation and data hiding. Encapsulation and data hiding is one of the 4 main features of object-oriented programming. Actually, my plan for this course is not to jump to Python coding directly. We'll explore the fundamental concepts of object-oriented programming first, and after building the foundation, we'll see how these features and many other features are implemented in Python. So we'll come to Python coding after approximately 4 or 5 lectures. Okay, now this is what I told you about objects in the last session. These are the main building blocks of an object-oriented programs. While designing an object-oriented application, we always start by identifying and developing objects, and then we interlink them with each other and with the main program until we achieve the desired goal, right? Now, each object, it is composed of 2 parts, data and behaviors. This is what I told you about data, that data represents the state of an object, and this term can also be called attributes, fields, properties, or simply variables. Whereas behavior means what an object can do, right? And we specify the behavior of an object through methods, right? They can also be called operations or functions, but method is a more common term. Now, let's have a look at an example. Let's suppose I want to define an object called mammals. We all know what mammals are. Now, think about what attributes can a mammal have. Here is a list of some attributes that I could think of. Number of limbs. All mammals have a certain number of limbs, 2 or 4. Every mammal can have a specific eye color, and we can also define some specific habitat for each mammal. So these are some of the attributes that or the properties that can define a mammal. Now think about the behavior that mammals can have. All mammals can eat, they can talk, and they can walk, right? Now some of you might be thinking that what kind of example is this? Like, we do not usually use such examples or such objects in while coding a program. So you are right, this is a little metaphoric example, and we'll be using such examples throughout, because such examples, they make you understand the concept in a much better way. So we'll be using both kinds of examples, a metaphoric example as well as real world example. Okay, now let's have a look at some more practical examples which we actually use while coding programs. What I'll do here is I'll list some objects here, and we'll try to identify attributes and behaviors for those objects. So the first object that I am considering is employee. It's a very, very well-known object when it comes to programming. So there could be a number of attributes associated with this employee. Here are some. An employee can have an employee ID. You can also define gender, designation, and date of birth for each employee. And we know that all these fields, they can easily be stored in a program, right? Now, what behavior can I associate with this object employee? So here are some methods that we can define for this. The first one, getter, setter methods for attributes. We'll leave this for the next slide. I'll be coming to this shortly. The remaining 2 methods, calculate salary and find retirement date, they are, they can easily be programmed. You can write code for these. For example, a person usually retires at the age of 60. So you can always find retirement date using this attribute, date of birth. Now, the second object that I am defining here is drawing shape. By drawing shape means the shapes that can be drawn. You can draw these shapes. Now, what attributes can I associate with this object? A drawing shape can have a color. And since I'm not telling what kind of shapes, 2D shapes or 3D shapes, so you can store that information in a field as well. Now, what functions can I implement here, or what methods can I implement here? I can find area of any shape, any 2D or 3D shape, and I can also find volume for 3D shapes, although I cannot use this method for 2D shapes, but this is just an example. Now, the third object that I am defining here is vehicle. We know there is a number of so many types of different vehicles, each having different attributes. So here are some attributes that I can think of about vehicles. Color, we can always identify the color of a vehicle. Number of wheels, model number, and here are a set of methods that I can define for the same. We can find mileage, we can find depreciated cost, although it sounds a little bit related to economics, but obviously it has a formula, and that can always be programmed. Okay, now getter and setter methods, these are special methods that provide controlled access to the attributes of an object. Getter is a special method that retrieves value of an object attribute. That means if you call this function for a specific attribute, it will return to you the value that is associated with that attribute. And similarly, setter method, it performs the converse function, and it helps you to set a specific value for an attribute within an object. Right now, these functions, they are also called accessor methods or mutator methods respectively. Now, the point here is that we are not allowing the main program or any other object to access attributes of a particular objects directly, right? Like, it provides a kind of data hiding. So the user of your object is not concerned with what names you are using for those attributes, and you can even set some limit checking parameters within this setter function, right? So basically the idea is to provide controlled access to the object's user. Now let's revisit this example of vehicles. Here we defined three attributes: color, number of wheels, and model numbers. And these functions highlighted in red, they show you the getter and setter functions for each of them. So for example, if I want to set number of wheels to 2, so what I'll do, I'll just call this function set number of wheels, and I'll pass number 2 or value 2 as a parameter to this function, and this function will in turn assign that value to this particular attribute number of wheels. Similarly, get number of wheels will return 2 to me. That means it will return the value that is associated with this number of wheels. Now let's suppose if I change the name of this attribute number of wheels to just wheels, then it won't make any difference to the user, because he or she is not accessing that attribute directly. They are just calling the functions. As long as I keep the name of these functions same, it doesn't matter what names I am using at the backend within the object for some attribute. Okay, now let's have a look at this term class. This is also a very fundamental term in object-oriented programming paradigm, and we have been seeing this term in the last semester as well, and there I told you to just take it as type of an object. Now here we'll define it formally. A class is simply a blueprint for an object, and it defines the type of an object. Now what happens, let's suppose in a scenario you have identified an object and now you want to write some code for it. So the object-oriented programming language that you are using, or every object-oriented programming language, it provides certain special constructs that you can use to define a class. If you recall, we use some special constructs to define a function, like that def keyword, and then there were special constructs to define loops, and there were special constructs to define while and other decision-making structures. Similarly, there are special constructs for class as well. So what you do, you will use those constructs to define a class. You set a name for that class. You define or select names for the attributes that you want to associate with this class. And then you define the functions. You set names for those functions. And you see, what a class actually is, it's just a piece of code. That's why I'm calling it a blueprint. Your machine does not allocate any memory for this class until and unless you try to use this class in a program. So if I want to use this class in my program from in my main program, or in some other function, or from some other class, from some other object, what you will do, you will make or define object of this class. So this is just a blueprint, this is just a code, and when you define object for that class, then your machine allocates memory for your object, keeping in view this blueprint. Like, this blueprint will tell the machine that what kind of object you are defining and what kind of attributes will this object have, and how much memory should the machine allocate for that particular object, right? Now, this process of making object is called instantiation. Like, you are instantiating an object of a particular class, right? Now, that means that this class, this is just a blueprint, and then you can instantiate as many objects as you need in a program for the same class. Now, let's have a look at an example. Let's suppose I define a class called pen. Now, this looks like a blueprint. Actually, I have tried to make it a blueprint. So I'm making a class of pen, and I'm writing code for this. I use the construct to define this class. I assigned it the name pen. And this is a small list of attributes and functions that I associated or I wrote for this class or within this class. Pen type, case color, ink type. These are some attributes that I am associating with this class. And write is a function. For example, let's suppose if you call this function, you can just make it write something on a screen in some specific format, font, or using some specific color. So this is what this function can do. This is one possible implementation of this function. Now, this is just a class. Like, you are writing just a piece of code. Now, if you want to instantiate an object of this class, let's suppose I instantiate an object, this piano crystal blue. This is an object of this class. This is a pen, and seeing this pen, I can set these attributes in a specific manner, like this. Now, I'm naming this object piano crystal, and I'm setting these attributes. I'm setting pen type to ballpoint. I'm setting case color to blue. I'm setting ink color to blue, and I'm setting ink type to oil based. And of course, if I call this function associated with this object piano crystal, then it will write in a way, you can make that function write in a way this pen writes, right? Now, similarly, I can instantiate another object of the same class. Let's suppose now I define this black piano crystal, and for this again I can set these attributes differently. Now, the point here is that whenever you instantiate an object, your machine allocates memory for it, and for every object your machine allocates a separate set of memory. So for piano crystal blue, your machine will be allocating some different memory locations, and for piano crystal black, your machine will be allocating some other locations. So the point here is that these two objects, blue piano crystal and black piano crystal, they are entirely different entities. Although they share the same class, they share the blueprint, they are of similar type, but they are they are actually different objects. Similarly, I can define another object. Let's suppose this Parker brushed metal, and then I can set all these properties for this new type of pen also. Pen type, I'm setting it to rollerball, case color is silver, ink color is black, and ink type is gel. So see, these are three objects which are different entities, right? But since they are similar in making, so they can all share the same blueprint. Okay, now this is another example. Here I'm defining a class for car. Now this is a blueprint which is fortunately blue in color too. Here you can see that I have associated this name car with class, so that's the class name, and I have associated some attributes: color, metal number, car cc. By car cc I means 1800 cc or 1000 cc. Actually, I don't know what this parameter actually defines, but we usually use this to compare, merits of cars. So therefore, I just put it there. Now, the method here is find mileage. You can always put a formula for finding mileage in it, and that can be used to find mileage for a specific car. Now, this is just a definition of a class. This is a code. This is a blueprint. Now, if I want to allocate memory for this, what I'll do, I'll instantiate object of this class. So the first object that I'm making here is this Suzuki Cultus 1, and I have set the attributes accordingly, seeing the picture. I didn't know the model number, so I just put the year there, right? And it's a 1000 cc car. Similarly, I can instantiate another object. Suzuki Cultus 2, it's relatively a newer model of 2017, and it's again a 1000cc car, but its color is blue. And then I can define another object, Honda Civic. It's blue in color. I fortunately know the model number as well, and it's a 1800cc car. Now these three objects, they'll be allocated different memories, and since they are different objects, they will not interfere with each other, although they share the same class or the same blueprint, but still they are different objects. Okay, now let's have a look at a relatively familiar example from Python. In CP, we learned that everything in Python is an object. And in Python, we can define different types of data. Here is a list of few, the most common ones, and we all are familiar with these. There we also learned that each of these data item is an object, like 1234 is an object, 3.1419 is an object, hello world string is an object, right? Now, since each of them is an object, that means it must belong to a specific class. So Python defines a class for each of these types. For example, 1234, it belongs to class integer. At that stage, when we were studying CP, we did not have enough idea about classes and objects. So we used to say that 1234 is of type integer. But now I can easily say that 1234 is an object which belongs to class integer, right? Similarly, 3.1419 is an object which belongs to class float. Hello world is a string type object. 157 ABC is a list type object, and the last one, CA California, is a dictionary type object, right? So as I said earlier, that a class is just a piece of code. So Python must have defined these classes at the backend, and when we define a data, let's suppose I'm defining 1234 and assigning it to some variable, or just using it as a constant, that means that I am instantiating an object of that class integer, right? So Python has code for this class, integer class, and then I can simply instantiate an object of this class, right? Similarly, let's suppose class list. You can define a number of different objects for this class. This is an object that belongs to this class. This is another object which contains all strings. This is also a list type of a object. This is another list object. This is another list object, right? That means that using a single class, you can define as many objects as you want. Okay, as I just said, these four objects, they belong to the class list. Now, since list is a class, that means it must be having a set of attributes and a set of methods associated with it. Now, if you recall, we had been using some methods with list type objects or list type variables. Here is a list of few of them: insert, remove, sort, reverse, and we had been using them frequently in CP, right? Now, I also told you that each instantiated object has its own data and behaviors, right? Or methods, its own data and methods, right? So that means whenever you define an object, a separate set of method and attributes is defined for that particular objects. So each of these method, I can call each of these method for any of these object, and that method won't interfere. And how does that happen? Let's see an example for that. We used to use the dot operator for that. Now, 123 is a list kind of a object, and if I write this 123 dot sort, that means that I'm calling this method sort on this particular list. Now, this is not a very good way of calling this method, because this will sort the list, but you won't be able to access the sorted list afterwards. So a better method is to assign this list to a variable, let's suppose L, and then call the sort method on L. Then you can view L later, right? Now, L dot sort, similarly, I can call the same method for the second object, Ali, Mishal, Kiran, that name list. Let's suppose I'm assigning this list to a variable name, and then I'm calling the same method on that variable. Now, name dot sort and L dot sort, they won't interfere with each other because they belong to different objects. L is a different object, and name is a different object, right? Now you have a fair idea of what objects and classes are. So let's move on to features of object-oriented programming. These are the four main features of object-oriented programming paradigm: encapsulation and data hiding, inheritance, polymorphism, and association. And every object-oriented language must provide syntax to implement these features, along with structures and syntax for defining classes and object. Right? Now, we'll see each of these in detail. Okay, now let's see what encapsulation is and what data hiding is. Encapsulation means putting data and behaviors in a single object. We have already discussed this, that when you define a class, what you do, you put the attributes and methods together in a cover or a capsule. That's why it's called encapsulation. And by data hiding, we mean that an object or a class, it can hide whatever it wants to from the outside world. By outside world, I mean the main program where you are instantiating that object. Uh, what we were doing, you write code for a class, that's just a code, and if you want to instantiate an object, you do that in the main program. See, okay, so that means that main program is the outside world for us. So whatever uh, attributes or methods an object or a class reveal to the outside world, that makes up the interface of that class. So interface actually provides a way of communication between objects. Now, how a class or an object restrict access to its attributes and methods? That is done through access specifiers or access modifiers. There are three types of access specifiers: public, private, and protected. And you can make each of your attribute or method public or private or protected. Like I can define a public attribute, or I can define a private attribute, or I can define a protected attribute. And the same goes for methods also. So if I am defining an attribute as public, that means it is accessible from everywhere. By everywhere, I mean it is accessible from within the class. That means the methods of that class can access that variable, right? And it is also accessible to the outside world, right, from the main program. But if I am defining an attribute or a method as private, that means it is not accessible from the outside world. It can only be used within the class, right? For example, why I would do this? Let's suppose you are defining a variable within a class to implement certain function, and that variable is used as a counter for some loop, right? So now, we don't need to show that counter variable to the outside world. Like, nobody is concerned with why it is used and how it is used. So you can keep it private, and in that case, its value or its name, it won't be visible to the outside world, right? Now, protected. The third type, protected, actually this one is related to a concept called inheritance, which we have not seen so far. So let's delay this until we study inheritance. Now, in a program, what we usually do, the attributes, they are made private. The outside world or the main program hardly accesses any attribute. This is a regular practice. And the methods, they are usually made public. That means methods, they form part of the interface, right? Now, if attributes are private, how they are accessed from the outside world? Obviously, they are accessed through getters and setters functions. And we have already discussed these getter-setter functions. And basically, there we discussed the same thing, that you can hide the attributes from the outside world, so that what name you give to your attributes or when you are changing them, that is not visible to the outside world. But if you want to access them or you want to change them, you just play with the values. You use setter functions to assign values to these unseen attributes, and then you can retrieve values for these unseen attributes, right? Okay, now let's see an example. I'm defining a class power to find power of a number. So here's my class. As you can see, name of this class is power, and it consists of two attributes, base and exp. Exp stands for exponent, and it contains only one function, find power. Now this function, what it does, it returns base raised to power exp. So basically it's calculating power. Now many of you might be thinking that why I am defining this complex function power when I have a very simple function in Python and other languages for the same purpose. In fact, we have a very nice double steric operator too. You are absolutely right. I'm just using this as an easily understandable example for explaining this concept, encapsulation and data hiding, right? Now, so just stick to it and initially assume that both these attributes, base and exp, and the single function find power, they are all public. And by public, I mean that they are accessible from the main code or from the outside world. Now, this class is just a blueprint or a piece of code. Now, if I want to access this class, what I would do, I would instantiate an object of this class in the main program. So let's instantiate an object called P1. Now, this P1 object, it will be able to access these two attributes, base and exp, as well as this single method, find power, from the main program. And if you recall how we had been calling methods on strings and list, we had been using that dot operator. So most languages use dot operator to access attributes and method of a specific class. So I would write p1 dot base to access this base attribute. I would write p1 dot exp to access or alter or change exp attribute, and I would write p1 dot find power to change to call this method find power. Now I want you to notice something here, that this method find power, it does not take any parameter or arguments. Actually, the rule is that all the attributes which are defined within a class, they are accessible to all the methods of that class. Like, you don't need to pass them to pass the attributes explicitly to any method of the same class. So that's why I don't need to pass any parameters to this method find power. Right now, let me show you a small code snippet on how can I use this class. Now let's suppose I want to calculate 2 raised to power 3. So this is what I would do. I would write p1 dot base is equals to 2. This statement will assign this value 2 to base attribute, right? And then I would write p1 dot exp is equals to 3. So this will assign value 3 to exp attribute. And now after that I am calling this function, this method p1 dot find power without any arguments. So, but since I have already set these values for base and exp, this function will calculate 2 raised to power 3. Let's suppose its implementation does that, and it will return the result which I am saving here in another variable called result, right? Now, where is encapsulation? Actually, what we are doing here is we are tying these two attributes base and exp and this method find power with this object p1. This is encapsulation, right? Like, you cannot access these attributes or this method without instantiating an object of this class. Like, if I just write base is equals to 2 and exp is equals to 3 and result is equals to find power, like calling that method, that would generate error, that would generate syntactic error in a program, right? So you cannot access it without using this object p1. That means that these attributes and these methods, they are actually encapsulated in this object p1, right? That is the reason that when you define another object p2, since you are defining a different object, then these base, exponent and find power, they'll be defined differently for that object. So that's why those set of attributes and this set of attributes, like attributes of p2 and attributes of p1, they do not interfere with each other. Now let's see how this class is hiding data. As I told you, we are assuming that all these attributes and this method find power, they are all public, right? That means they can be accessed from the main program. Now let's consider case 1. In case 1, what I would do, I would define some getter and setter methods for these attributes. Like, I don't want these attributes to be accessed from the main program. So what I am doing, I am writing some getter setter functions so that if user wants to set values for these attributes or user want to see values of these attributes, he or she can call those getter setter methods. So he won't need to access these attributes directly. So let's define some getter setter methods here. So I'm defining here 4 methods. Set base x. So whenever we call this method from the main program, what we'll do, we'll pass a value x to it, and this function will just assign this value to the attribute base. So it would be a one-liner function. It would just contain a single statement, base is equals to x. So it will just set base to this value x, right? It could be any value sent by the user from the main program. Similarly, get base, it will also be a one-liner function. It will just return base. So since we assigned, let's suppose we have assigned x to base, so the value that will be returned to the main program will be x, right? So similarly, we can implement set exp function and get exp function. So setters, they require arguments which can be assigned to the attributes, whereas getters, they are usually simply returning the values to the user or to the caller, right? Now uh, let's suppose we have made these functions. Now, do you think that this restricts access from the outside? Like, can the user still access those attributes, base and exponent, or not? So the answer is yes. Since these attributes are public too, so they can also be accessed from the outside. Like if the user of this class knows the names or variable names of these attributes, base and exp, he or she can easily call these through that instantiated object p1, right? Now let me give you an example. Let's suppose we are just using these getter setters to access these attributes. So what I would write this p1 dot set base 2. So this is a setter function. It will assign base is equals to 2, and p1 dot set exp 3. So this will assign a value 3 to exp, right? Now if I call this function find power, it will return me 2 raised to power 3, right? So this is absolutely fine. But if the user knows the name of my attributes, he or she can write a code like this too, like we had been doing on the last slide, right? And the problem is both are syntactically correct. Your compiler or interpreter won't generate any error on any of these code. So although you are trying to limit access to these attributes, but since these attributes, they are public, you are actually not limiting access to them through getter setter functions. So if you want to do that, for that we'll consider another case 2. Now what we'll do in case 2? In case 2, we'll define getter setter methods, but at the same time we'll make these attributes private. And if you recall, I defined private attributes or private methods as the ones which cannot be accessed from the main program, although they can be accessed within the class. Like this function find power, it can access these two attributes, but these two attributes, they are not accessible directly from the outside class. Now what will be the accessibility of different portions of this class? These attributes, they won't be visible to the outside world because they have been declared private, whereas all these 5 methods, they are still public, so the user can access all these methods. Now if I write this code, this is absolutely fine, like we had been doing before. But now if I write this, the first 2 statements, p1 dot base and p1 dot exp, that will raise error because these 2 attributes, they are public. So these 2 statements, they cannot be written in the main code, right? Although last statement is absolutely fine, since that method is a public method, it can easily be accessed through this object p1. So now this is a better or a standard way of defining a class. You usually do not show your attributes to the outside world, and if you want to do that, you just make them private. So as I said earlier, usually what we do in a class, we make the attributes private and the methods are usually kept public. Okay, now what's the use? Let's suppose I am the coder of this class. I have written this class. This is my code. And you are instantiating objects of my class in your program. So that means you are the user of my class. So you have written your program and it is working just fine. But at some later point of time, I decide to change the name of any of these attributes. Let's suppose I don't like exp. I want to change it to e only, right? Or let's suppose something else like power or anything else. So if I am doing that, since this exp was private and it was not accessible to you, so my changing this variable name will not affect your code. Your code will still work fine, and whatever I'm doing inside, if it is a private attribute or if it is a private method, that won't affect your program, right? Now similarly, if I try to change implementation of any of these 5 methods, let's suppose find power, consider this as the first implementation. Let's suppose this was the first implementation for my function, for my method find power. I'm using a simple loop to repeatedly multiply base by itself. Uh, how many times? Exp times, right? That will give me the desired result. Let's suppose at some later point of time uh, I decide that why should I use this? I have a simpler double steric operator available. I should have used that. Why should I write such long code of 4 lines when I can write just a single line? So if I change the implementation of this function, find power, then also your code will keep working fine, because this is some inner implementation of my class. Whatever I do inside the class with things, with attributes and with implementations that are not visible to the outside class, that won't outside the class, that won't affect your code, right? So your code is still working fine, although I have changed name of a variable of an attribute, and I have changed implementation of a method, but still your code works fine. So this is the power of data hiding. That means no one needs to know how the class is implemented at the backend. You can do whatever you want inside the class, as long as the interface remains same. Like, I cannot change the name of these functions, because if I change the name of these functions, since they are public, then your code will be affected. Otherwise, there won't be any effect on your code. Okay, now let's have a quick recap of what we have done today. We saw what classes are. Classes are simply blueprints or code snippets which can be used to instantiate objects. We can instantiate as many objects from a class blueprint as we need. Each instantiated object will have its own set of attributes and behaviors. They do not interfere with each other. Then we saw these are the 4 main features: encapsulation and data hiding, inheritance, polymorphism, association. These are the 4 main strengths or 4 main features of object-oriented programming paradigm. And then we saw what encapsulation and data hiding is. Data and behaviors, they can be encapsulated in a single object, enabling it to hide whatever it wants from other objects. Okay. Now we'll discuss the remaining features in the upcoming classes. For now, this is it. Thank you.